Hello class, we're about to start on the Math 20 Exam 2 review for chapters 4 and 5. Now, this is how we're going to do this. We're going to go from problems 1 through 27 to cover the upcoming exam that we have for exam 2. It says write 3 and 5/6 as an improper fraction. Okay, first of all, we know that with the improper fraction, our denominator stays the same. So our denominator would be 6. To find our numerator, we would take 3 times 6, which is 18, plus 5, which would give us 23. And that is our final answer. Now we go to number 2. We want to write 33 divided by 4 as a mixed number. So we would take 4 divided by 33, and we say 4 goes into 33 8 times. 8 times 4 is 32. And we have a remainder of 1. Okay, now, with our answer, our denominator does not change for the fraction. Our integer is the number in front of the remainder, which is 8. And our numerator is the number after the remainder, which is 1. So our final answer here is 8 1/4. Okay, now we scroll down to number 3. We have 1/3 times a negative 2/5. Now remember, when we multiply, we can multiply straight across. But first, let's look at the signs here. We have a positive times a negative, which we know is a negative. Then we will multiply our numerator. 1 times 2 is 2, and 3 times 5 is 15. So our final answer here is a negative 2/15. Now we go here. We have 1/4 times 8 over 11. Now what's different about number 4 than number 3 is these were all prime numbers and also 1. So we did not have to break them up into their prime factorization. These are not all prime numbers, so we need to break this up into the prime factorization. Now we don't have to write the 1, but 8's prime factorization is 2 times 2 times 2. Now we look at our denominator. 4 prime factorization is 2 times 2, and 11 is prime, so it'll be times 11. Now we simplify. We simplify all of the terms they have in common. And this happens to be that they have 2 sets of 2's in common. So our final answer would leave us 2 for our numerator, 11 for our denominator. And we're done with number 4. Now we scroll down here to number 5. We have 7/15 divided by 21 over 35. So our first term stays the same, which is 7/15. Division becomes multiplication, and we take the reciprocal or flip the second fraction. Now again, we could break this up into prime factorization. 7 is prime, and the prime factorization of 35 is 7 times 5. Now for our denominator, 15's prime factorization is 3 times 5. 21's prime factorization is 3 times 7. Now we simplify out all of the terms they have in common. They have a 7 in common, and we also have a 5 in common. Now for our final answer, our numerator is 7, our denominator is 9. Now we move on to number 6. Let's look at the sign first. A negative divided by a negative is positive. So we know our final answer is going to be positive. So we could write this first fraction without the negative sign, change division to multiplication, and write the second fraction without the negative sign after we take the reciprocal. Now we take the prime factorization of the numerator. 3 is prime, and the prime factorization of 28 is 2 times 2 times 7. Now for the denominator, 7 is prime, and the prime factorization of 9 is 3 times 3. Now we simplify out all the terms they have in common. They have 1 set of 3 in common and 1 set of 7's in common. So our numerator here would be 2 times 2, which is 4, and our denominator would be 3. Now we were not asked to make this into a mixed number, and we did not start off with a mixed number. So this simplified version of this improper fraction is fine. Now we go down here to number 7 and 8. Now remember, with problems like this, when you have 0 first, 0 divided by any number except 0 equals 0. And then number 8, since the 0 is second, any number except 0 divided by 0 is undefined. Now we go down here to number 9. We have add. We know in order to add fractions, they must have the same denominator, which we have here. So our denominator is 15, and we add our numerators. 4 plus 7 is 11. And they have nothing in common, so we're done. Now with number 10, it says add. Now we have a negative and a positive. We know when we have a negative and a positive, we're actually going to subtract. So they still have to have the same denominator. So 11 would be our denominator. Now this is negative 6 plus 5. Negative 6 plus 5 is negative 1. And this is the final answer for number 10. Now we're at problem number 11. It says find the prime factorization of 174. So we will write 174. Now since this is an even number, we know 2 goes into it. So we will have 2 times, now this will end up being 87. 2 times 87, 2 is prime. Now 87, if we add these 2 digits together, remember we talked about the divisibility rule of 3. 8 plus 7 is 15, and 3 can go into 15. So we know 3 can go into 87. 3 goes into 87, it looks as though it goes 29 times. 3 is prime, and 29 is also prime. So the prime factorization of 174 is 2 times 3 times 29. And that is the prime factorization of 174. Now, we go over here to number 12. It says find the prime factorization of 135. Now, since this number ends in 5, we know 5 goes into it. So this would be 5 times 27. 5 is prime. Now 27 we know can be broken down to 3 times 9. 3 is prime, but 9 is not. So this would be broken down to 3 times 3. So now for the prime factorization of this number here, we will have 3 times 3 times 3 times 5. Now this is one way to write the solution, but since we have multiple factors here, we could write it like this as well. We could write it using exponents. It would be 3 to the third power times 5. So either one of these answers will be acceptable if the directions do not specifically tell you to write this as an exponent. Now we come down here to problem 13. We have 1/8 is equal to blank over 32. So remember I told you all before, you could say this. You could say 32, the larger number, divided by the smaller number. 32 divided by 8, we know is 4. So really, we're multiplying this lower fraction by 4 over 4. 4 times 1 is 4, and 4 times 8 is 32. So this is our answer for 13. Now we come to 14. Now we have 12 and 108. Now it's kind of hard sometimes to think this out because this is a larger number. So this is what we could do. We could take the prime factorization of 12 and 108. Prime factorization of 12, we add 3 times 4, and 4 becomes 2 times 2. So the prime factorization of 12 is 2 2s and a 3. Now with 108, you add 2 times 54, and then we will have 6 times 9, and 6 becomes 2 times 3, and 9 becomes 3 times 3. So the prime factorization of 108 is basically we add 2 2s and 3 3s. And they're all multiplied to each other. So this is what we do. We do a comparison. We ask ourselves, what does 108 have that 12 does not? Now if you notice here, 12 has 2 2s and a 3. 108 has that, but it also has 2 other 3s. So it has 9. So we will multiply this numerator and denominator by 9. 9 times 12 is 108. 9 times 6 is 54. And that takes care of problem number 14. Now we want to go down here. Now we have the fractions that have different denominators. So what we have to do here, again, prime factorization. We got 3 and 9. 3 is prime, 9 is not. 9 prime factorization is 3 times 3. Now, we will write down the prime factorization of 3 here, and we notice that we have one set of 3's that match up and one 3 extra. So it'll be 3 times 3, which is 9. That's their least common denominator. So we know 9 is their denominator. Now, this is what we do here. We look at 3 and we say, what does 9 have that 3 does not? It has an extra 3. So we'll multiply this fraction by 3 over 3. We know 3 times 3 is 9. 3 times 2 is 6. Now we look here. We compare 9 with 3. We say, what does 3 have that 9 does not? It doesn't have anything that 9 does not. So we will bring down the same fraction that had the 9 in the denominator. So now we add. 6 plus 2 is 8, and our denominator stays 9. So that is it for problem 15. Now we go to 16. We have 4, we have 5 for our denominator. 4 prime factorization is 2 times 2, and 5 prime factorization is just 5. Now we look here. Now we will build our least common denominator. There's no numbers matching up, so we will bring all the prime numbers down and multiply them, which will give you 20. So our common denominator here is 20. Now we ask ourselves, what does 5 have that 4 does not? It has a 5. So we multiply our numerator and denominator by 5. 5 times 4 is 20. 5 times 1 is 5. Now we ask ourselves with the 5 in comparison to the 4. What does 4 have that 5 does not? It has 2 2's, which is 4. So we'll multiply this numerator and denominator by 4. 5 times 4 is 20. 3 times 4 is 12. So now we add them. 5 plus 12 is 17, all over 20. And we cannot simplify this, so that is your final answer. Now we come here to problem number 17. Now we already know the prime factorization of 9, which is 3 and 3. Now we do the prime factorization of 15, which is 3 and 5. Now if you notice here, we do have 3's that match up, so we will count that once. And then we have two factors left that don't match up with anything. So our least common denominator would be 3 times 3 is 9 times 5 is 45. So our least common denominator is 45. Now we do a comparison. What does 15 have that 9 does not? It has a 5. So we multiply this numerator and denominator by 5. 5 times 7 is 35. Now here we compare 15 to 9. What does 9 have that 15 does not? It has an extra 3. So we'll multiply this numerator and denominator by 3. 15 times 3 is 45, and 2 times 3 is 6. So now we take 35 minus 6, which will give us 29, and our denominator stays 45. And they have nothing else in common, so our final answer is 29 over 45. Now we come here. Now this is a negative and a positive, so we know we subtract. So we could take the prime factorization of 8, which is 2 times 4, and then 2 and 2. Take the prime factorization of 4, which is 2 times 2. So we add 3 2's for the 8 and 2 2's for the 4. Now we add 2 sets of 2's that match up. So we'll write those once. So we add 2 times 2, and we add the extra 2, which is 8. So our common denominator here is 8. Now we know that 4 doesn't have anything that 8 doesn't have, so we'll bring down this negative 1. Now when we compare 4 to 8, 8 has an extra 2 that 4 does not. So we multiply numerator and denominator by 2. 3 times 2 is 6, and 4 times 2 is 8. When we add these together, negative 1 plus 6 is 5. And we keep our denominators the same because we subtract because they have different signs. And that's it for problem number 18.